So thermal decomposition of metal compounds. This is another very useful application of reactivity series. Or basically, if we want to know that which metal compound is more stable, more resistant to heat, will not decompose, sometimes safe to use, sometimes easier to dry in the oven, we need some idea. And the idea is straight away given by what? The reactivity series. Like if a question says it is copper sulfate compound, copper sulfate crystals, and you want to dry them, what the best option is? Oven or folds of filter paper? You will say folds of filter paper, because less reactive metal, when it is less reactive metal, then its compound is unstable. So if you will dry it in the oven, it may decompose. Better it is to dry in the folds of filter paper. What the idea is behind? A metal which is higher in the reactivity series, mean more reactive, will produce stable compounds, resistant to heat. But metal which is low in the reactivity series will produce less stable compound, easier to decompose, less temperature needed. Sometimes even the compound metals like silver, which are much below, their compounds are kept inside dark bottles, opaque bottles, because even the sunlight can decompose them. That is why silver chloride or bromide is used on photochromic glasses, because sunlight is able to decompose it. Okay, copper compounds, unstable they are, copper carbonate green, if you place in sunlight it may break down. Copper sulfate, heat it too much, there will be no crystals, rather it decomposes. So better it is to heat gently. When they say heat gently, it means metal is lower in the reactivity series. But if the metal is higher in the reactivity series, its compound is highly stable, it needs very high temperature to decompose, okay, depending on its position. You can always keep this idea from the fact that sodium is higher in the reactivity series, and sodium chloride ores are all around, and you keep sodium chloride, even you keep sodium chloride, add sodium chloride in food stuff, cooking, and provide lots of heat, but you won't heard anyone saying this, the sodium chloride is decomposed to sodium metal and poisonous chlorine gas. Mean metal higher in the reactivity series, its compound is very stable, highly stable. Always remember, higher a metal, highly stable its compound is, resistant to heat. That is why if the metals are higher in the reactivity series, we'll see in the extraction, like these metals, their compounds are so stable that their ores are so stable that they are changed into pure metals only by electrolysis, the feasible method. Because if we want to heat them and react with the reducing agent like carbon or other, we need a very, very high energy, not a feasible process. Also carbon is below, so it's not going to displace them so easily. Extremely high temperatures may be needed. So that's not a feasible process. Electrolysis is feasible in that case. But lower metal, less reactive, the less stable their compounds are, heating with a reducing agent actually enable us to obtain the metals in the pure form. So you can see here calcium carbonate. The carbonates, when decomposes, they produce oxide of metal and carbon dioxide. And nitrates, when decomposes, they produce oxides of the metal, but along with two gases are formed. One is toxic nitrogen dioxide. This is a yellow gas, yellowish observation it may be, and this is toxic. When metal nitrates are heated, a precaution is always heat them in a fume cupboard. Poisonous toxic fumes can kill, okay, but idea is same for both. Higher the metal in the reactivity series, their carbonates are stable. Higher the metal in the reactivity series, their chlorides are stable, sulfates are stable, nitrates are stable. So you can see here, same mass if you take of all these carbonates, you will find out the higher volume in a less time will be produced by copper. Never go for more reactive and producing more volume. No, more reactive producing less volume in the same amount of time. Copper carbonate will quickly decompose and fill your gas cylinder earlier. So most common mistakes normally students see more reactive metal, easier for the test tube or the gas jar to fill in. No, more reactive, its compound is resistant, highly stable, you need very high temperature, it will take more time. Less reactive metal, less stable its compound is, lesser temperature you need, and it will break down so easily and produce carbon dioxide and fill your gas cylinder quickly, okay. So if the same amount of the mass is used and different volumes of the gases are given, and same time they are asking about the reactivity series, to make order of the reactivity series based on those observations, you will always find out, you will always see it, that higher the volume, it means less stable the metal is, less reactive the metal is. And lesser the volume produce, more stable the metal, basically, and higher in the reactivity series. So the basic idea you need to keep in the mind to solve such problems is more reactive, more stable compound it produces, high temperature it needs, more time it needs to fill the gas cylinder, less volume it will produce in the same amount of time as compared to the metal which is lower in the reactivity series. Okay, so metals, thermal decomposition of metal compounds is again related to their position in the reactivity series. Okay, carbonates decomposes to their oxides, nitrate decomposes to oxides and nitrogen dioxide and oxygen gas, but idea is always, the fact is their position. You need to look at the position, then make a decision how much time it may take if a certain data is given in a handling information question. Okay, like I said, silver chloride is kept in, or silver compounds are kept in opaque bottle, dark bottle, just because light can decompose them. So these are basically certain important applications of reactivity series, that we check their stability of the metal compounds, we check their displacement, and we also get an idea about extraction of metals, and we also get about the process which we are going to use in extraction of metal. Electrolysis for those which are higher in the reactivity, because their compounds are resistant, highly stable, you need electrolysis to carry out them. But if they are less reactive, easier processes, economical, reducing agent, you use heat, you will get the metals. Okay, so that is about applications of reactivity series.